So first we're going to create a new geometrical sets. And geometrical sets can be thought of as layers or levels within AutoCAD and MicroStation. And they're basically ways of organizing logical sets of geometry. They can actually contain more than geometry, but and you can actually nest geometrical sets inside of one another. But their primary focus is to create a logical grouping of elements. So we're going to go ahead and use the Insert Geometrical Set tool to create a new geometrical set. And you can see that it inserts it at the end of the list based off of whatever the active set is. So whatever set is underlined in the model is the one that is active at the moment. And geometrical sets can contain pretty much any geometry or numerical relationship except for solids. So CATIA draws a difference between wireframe and surfaces, which is basically all the construction geometry, and solids. Because it's primarily thought of as a manufacturing tool, the end goal is often perceived to be a solid element that's going to be manufactured. And so for our purposes, we're not going to really focus on those differences and mainly work within geometrical sets. But if you're wondering why this part body element is here, it basically is the equivalent of a geometrical set for solid elements. Now we're going to go ahead and create in our geometrical set a series of intersection points. And these intersection points are going to define everything that the frame will be built on. So we're going to go ahead and hide, let's go ahead and hide our axis system, and we're going to hide our reference points. And we're going to use the intersect tool. First we'll select our reference plane, and then we're going to use the multi-select tool to pick our guide splines. And we'll say OK. And that's effectively duplicating the endpoints of the lines. But instead of being based off of the lines, now it's based off the intersection of our plane in these lines. So you can imagine that as this is populated, this plane will then intersect with our lines and create a new set of points. This plane will intersect with our lines and create another set of points. And our frame element needs to be based off of these points only. So that's why I hid our original set of points, just so that we don't mistakenly select them. So now we're going to go ahead and select our reference plane, and we're going to switch to our position sketch tool, which I think is the default in Digital Project. But in CATIA it's called a position sketch. And it brings up a little menu. And since we pre-selected our plane, you can see that the reference is listed as plane. And we'll say OK. And so now you can see that the tools on the right changed because we're now inside of the sketch workbench. And so the sketch is where you can actually define constraint-based two-dimensional drawings. So I just switched using the normal view button so that we're now looking orthographically at our sketch plane. That's an option that I've set so that you have to do that manually. By default, I think it does it for you automatically, which some people prefer. The tool that we're going to use to draw our frame profile is called Profile. It's essentially a polyline tool. And you can see that as we start drawing, when the line turns blue, it means that it's automatically adding a constraint. So in this case, it's automatically adding a vertical constraint. So when we click, you can see the V added next to the line. That's creating a vertical constraint while we're drawing. And you can see it does the same for horizontal. And we're going to leave this segment free. It's not going to be horizontal nor vertical. And that's because down the line, this is the element that's actually changing as we instantiate each instance of the Powercopy. So now we'll create an additional horizontal line. We'll create our vertical line, and then we'll close the whole system, and you can see the little snap kind of icon pops up to indicate that you're snapping to that point. And we click there, it ends the command, and we have a closed profile. And you can see that even though we've created these vertical and horizontal constraints, there's still quite a bit of freedom and flexibility. And some of that you can see here is not something that we would necessarily want to happen, but essentially until we begin to define more constraints, there's still quite a bit of flexibility within this profile. And so the process of defining in Powercopy requires quite a bit of back and forth in establishing what degree of flexibility is needed and what degree of constraint is needed. So in this case, we're going to go ahead and create constraints between 4 of our corners, our vertices, and our 4 reference points that were created with the intersection tool. So we'll go ahead and use the control button to multi-select. So we selected the vertices, and you can see if you're having trouble picking something, if you hit the Alt tool and click, it brings up this interface which allows you to kind of specify more specifically which element you're trying to select, which is pretty useful. And once you've selected the 2 points, we're going to go over to the constraints box, or define in dialog box command. Click that. It opens up this menu, and we're going to use the coincidence constraint. And you can see that it basically moved the entire profile so that the point that we originally had that was out here is now coincident with our intersection point. And it's critical that we're selecting our intersection point rather than the endpoint of our splines or the hidden points that are defining the splines, because again, we want to make sure that the points are the ones that are actually created from the intersection of our reference planes and the splines. So we'll now use control to select these 2, and you can see that as long as it's highlighting the intersect within the tree, you know you're good. And we'll create another coincident constraint, and you can see it moved it into position. We'll now create a constraint between these 2 points, and then the final, and you can see that as we're making these constraints that more and more of the sketch is turning green, which indicates that it's defined or constrained, and a fully defined sketch will be completely green. So our last coincident constraint should make it completely green. So this is a way of indicating whether or not a sketch has any degrees of freedom left. You can also, there's also a visual indicator if you've over-constrained something. So let's say if we create a dimensional constraint here, you can see that everything turns purple, which is indicating that this is actually over-constrained, which is something that we don't want. So we'll go ahead and delete that. I just wanted to show you how over-constraining works. So once we've defined our profile sketch, we can exit the sketch workbench by clicking this icon. It looks a little different in Digital Project, but it should be in the same upper right position. So we'll click that. And now we're back out into the part editing workbench, and you can see all of the tools update. In CATIA, I'm actually working under the wireframe and surface design workbench. I think it's called the part design workbench in Digital Project, but the tools should look like this. So now we're going to define a reference line that we're going to use to create our frame profile on. So for a second, we're going to hide our sketch, and we're going to use the line tool to create a line between, again, making sure that we're using our intersect points between that intersect point and that intersect point on the bottom. We'll say OK. And then we're going to use our plane tool to create a plane through that's normal to curve. So if that doesn't automatically come up, you can switch it from this drop down, and you could see a plane that appears perpendicular to the line that we just made. and by default it goes to the middle, which is what we want. We'll say OK, and then we're going to click that plane, and we're going to click our position sketch tool. And the one thing that's important to set here, and this again is just based off of experience working with Powercopies, we want to change our origin so that it's not implicit to curve intersection. And we'll pick this line as our reference point. So basically this will ensure that as we instantiate the Powercopy, it updates the location of this sketch for each instance, rather than using the global origin, which is what it would use by default. So now we're inside of our sketch. We're going to use the normal view to switch to an orthogonal projection, and then we're going to draw a rectangular frame profile with the rectangle tool. And you can see that it automatically added horizontal and vertical constraints. So we can now exit out of our sketch, and we can turn our reference sketch back on. Oops. Hide show. And now we're actually going to define a couple parameters that we'll use to drive globally the frame width and height. So in order to make parameters, you click on this FX button, which is the formula button, and that brings up the formula definition menu. This list contains all of the formulas that are currently within the model, and so all of these things are actually implicit relationships that are created just through modeling operations. And you can also define your own explicit parameters through this set of tools here. So we want to make sure that our type is correct, and if you can see that by clicking on this menu, it brings this pop-up up with a list of all of the different parameter types, which there's hundreds probably. But you pretty much will only use things from area up, unless you're doing stuff that I don't even know what it does. But for now, we're going to use the length parameter because we're actually setting a numerical length for the width and height of the frame. And we click the new parameter of type length button, and we can rename it here. We'll call it frame width, and we'll give it a default value of 8 inches. And then we'll create another one, and we'll call this one frame height, and give that a value of 6 inches, and then we'll say OK. And you can see because of some options that I've set, I don't think it comes this way out of the box, but you can see that it adds the numerical parameters to the specification tree, and you can see the two named parameters, frame width and frame height, here. So this is an option that I'll go over the settings in another video if you want to display these within your specification tree. So now that we've defined a couple parameters, we're going to go ahead and double click on our sketch to go back into sketch editing mode. We'll go back into our normal view, and we'll zoom in a little bit, and we're going to add a couple dimensional constraints to our sketch to define the height and width. So a great shortcut that I just learned is if you double click on any tool, it keeps it active so that you can actually do a bunch of commands one after the other, and it means that you don't have to kind of go back and forth between the model and the icon, which is a really great shortcut to know. So we'll go ahead and create one dimensional constraint and create the second one, and then we can use the escape key to end the command. And now we want to double click on each one of our dimensional constraints and override these explicit numerical values, which you can change here and kind of see how it updates. We want to change those and actually right click inside of this value field and go to edit formula. And for this, we'll go up and click within our parameter tree the frame height parameter. and we'll say OK. You can see it fills in the name here, and we'll say OK. And now you can see that that box is gray, which means that it can only be edited from the associated parameter or by overriding that relationship here. And then we'll say OK one last time. And we'll do the same thing for our width parameter. Right click, edit formula, frame width, and OK. And you can see that the model updates. You can still see that even though we've added these dimensional constraints, that the frame is still free to move around on the definition plane. So we need to add one last constraint to make sure that the sketch is fully defined. And we'll do that by drawing a line that runs diagonally between two corners. And then we're going to define that line as construction geometry, because in this case we don't want this geometry to show up as part of our frame element. Otherwise you'll create self-intersecting surface geometry, which is always bad. And we'll do that by toggling using the construction standard element toggle here, which the location should be close to the top by default. And then we're going to define the midpoint of this line to be coincident with the origin of our sketch. So we control click to select two elements, and then go to our let's see. Oh, I think I have to actually pick the origin. There we go. So I pick the origin of the sketch. So this is available by opening our sketch, opening our absolute axis dropdown, and accessing the origin point. And we'll control click our line and go to our pop-up and click midpoint. You can see that now the midpoint of the line is constrained to the origin of our sketch. So now we have a fully defined profile. We can exit our sketch, and we're just about ready to make our frame geometry. So to make the frame, we're going to use the sweep tool, which is here. And the sweep tool has a lot of options. It can become pretty advanced, but this is a pretty simple sweep, so we're just going to use the profile, which we just created, and our guide curve, which was our original sketch. And we just click those from this specification tree, and we'll hit preview just to make sure that it looks right. So this is as expected. You can see that it actually automatically miters and cleans up corners really nicely. It's just a really great feature. And we'll say OK. So we've now created a surface which represents our frame. And you'll notice that all of this geometry is under one geometrical set, which means that even though this surface looks like a closed solid element, CATIA sees it as only a kind of hollow representation of a solid. So in order to make this a solid, I would have to perform additional modeling operations, and it would force me to put it into the part body set. So it's better to keep things as surface elements until you absolutely have to turn them into solids, because it makes the model much lighter and quicker to work with. And so for this kind of quick design exercise, we're going to leave it as a surface model.